Hello everyone, and welcome to our channel. Today, we're setting our sights on a groundbreaking project that's propelling India's space ambitions to new heights, the Agnibaan launch vehicle by Agnikul Cosmos. Buckle up, because we're about to delve into the fiery heart of this revolutionary rocket and explore its recent successful test flight. Agnikul Cosmos is an Indian space technology startup founded in 2017 by Srinath, Ravichandran and Sr. Chakravarthy from IIT Madras. Agnikul focuses on designing and building rockets that can carry small satellites into space. Agnibaan rocket is Agnikul's primary project. Agnibaan, meaning path of fire in Hindi, is a two-stage launch vehicle being developed by Agnikul Cosmos, which is a small satellite launch vehicle capable of carrying up to 100 kilograms of payload to low Earth orbit, which includes satellites like CubeSats, which are used for Earth observation, scientific research, communication, and tech demonstrations. This rocket is 18 meters long and has a diameter of 1.3 meters. It has a lift-off mass of 14,000 kilograms. The payload capacity of Agnibaan is stated to be around 100 kilograms in some sources, but Agnikul Cosmos' official website mentions a higher capability of carrying up to 300 kilograms to an altitude of 700 kilometers. We'll likely get a clearer picture as Agnikul releases more information about the rocket's specifications. The Agnibaan rocket has a two-stage design. Each stage uses the innovative Agnilet engine, which is fully 3D printed and powered by electric pumps. Although the exact thrust of each engine is not officially disclosed, it's estimated that the first stage uses 7 Agnilet engines, each producing about 25 kilonewtons of thrust. These engines burn a mixture of liquid oxygen and kerosene. The second stage has a single Agnilet engine optimized for space, with a longer burn time of around 355 seconds. Now when we talk about engines, the Agnilet engine is a groundbreaking achievement in rocket technology. It is the world's first single-piece 3D printed semi-cryogenic rocket engine. Traditional rocket engines are assembled from thousands of parts, but the Agnilet engine is made as one continuous piece using a 3D printer. Normally, building a rocket engine takes several weeks, but with 3D printing, Agnikul can produce an engine in about 75 hours. 3D printing of rocket engines, also known as additive manufacturing, involves creating the engine, layer by layer from a digital model. The printer's laser or electron beam melts the metal powder, layer by layer, following the digital design to fuse the metal into solid shapes. This process continues until the entire engine is constructed from the base to the top. After the engine is printed, it undergoes post-processing, including heat treatment, machining, or surface finishing, to ensure all parts meet the required specifications and performance standards. Now, let's talk about Agnikul's recent successful test of their Agnibaan SOrTeD rocket, stands for Suborbital Technological Demonstrator. On May 30, 2024, company achieved a historic milestone with the successful suborbital test flight of Agnibaan. This wasn't just any launch, but it was the first launch from a private launchpad in India, named Dhanush. The first flight of a 3D printed engine in a rocket in the world. And the first launch of a semi-cryogenic engine built entirely by an Indian private company. The suborbital rocket, weighing around 580 kilograms, reached its highest point, or apogee, around 20 kilometers above the Earth, carrying a payload of 7 kilograms, before safely splashing down in the Bay of Bengal, demonstrating the success of Agnikul's innovative technology. Agnibaan has only conducted a suborbital test so far because this type of test is crucial for evaluating the rocket's performance and technology before attempting a final orbital launch. This test flight is a type of spaceflight where the rocket reaches space but does not achieve the speed or altitude necessary to enter into orbit around the Earth. During a suborbital flight, the rocket follows a curved trajectory. It ascends to a high point, known as the apogee, and then descends back to Earth. The flight path does not complete a full orbit, so the rocket eventually falls back down due to gravity. This type of test flight allows engineers to test and verify the rocket's systems, such as the engines, flight controls, and structural integrity, without the complexity and higher costs of a full orbital launch. The Agnibaan rocket's test flight included several critical maneuvers. The first one was a lift-off. Lift-off is the exhilarating moment when the rocket successfully launches from the ground. For Agnibaan, this marked the beginning of its journey into space. The engines ignited and produced enough thrust to overcome Earth's gravity, propelling the rocket upwards. Liftoff is crucial because it sets the entire mission in motion, showing that all systems are good and the rocket is ready to embark on its path to space. Then about 4 seconds after liftoff, Agnibaan performed a pitch-over maneuver. This maneuver involves the controlled rotation of the rocket, changing its orientation from vertical to a specific angle. Instead of continuing straight up, the rocket tilts slightly to follow a curved path. This is essential for guiding the rocket onto the correct trajectory, ensuring it follows the planned path to reach its intended orbit or flight objective. At around 39 seconds into the flight, the Agnibaan rocket executed a wind biasing maneuver. This maneuver is all about adjusting the rocket's path to account for wind conditions. Even high in the atmosphere, winds can push the rocket off course. The rocket's sensors detect these wind forces, and the system makes small adjustments to ensure it stays on the correct trajectory. Wind biasing is important for maintaining a stable and accurate flight path despite the presence of atmospheric disturbances. Then next, the rocket reached its highest point, known as apogee, at 1 minute and 29 seconds into the flight. Apogee is the pinnacle of the rocket's flight path, the farthest point from Earth before it begins its descent. Reaching apogee means the rocket has successfully completed the upward phase of its journey, hitting the target altitude and marking a key milestone in the mission. And finally, the mission concluded with the rocket splashing down in the Bay of Bengal, just over 2 minutes after launch. Splashdown is when the rocket lands in the ocean at the end of its flight. For Agnibaan, this meant a safe conclusion to its mission. Splashdown ensures that the rocket components can be recovered and analyzed, providing valuable data for future missions. It also prevents any potential damage on land, making it a safe and effective way to end the mission. Each of these maneuvers played a vital role in the successful test flight of Agnibaan, showcasing the incredible technology and precise engineering behind this groundbreaking mission. Agnikul aims to use the data and experience gained from the recent suborbital test to refine their technology and ensure the success of future missions. Following the successful launch of the Agnibaan SOrTeD rocket, Agnikul Cosmos is set to take several exciting steps forward. This achievement marks a significant milestone, not just for the company but for India's private space sector. The next major goal for Agnikul is to achieve an orbital launch. The company plans to launch customized satellites into low Earth orbit by early 2025. This will be a crucial step in demonstrating their capability to provide reliable and cost-effective launch services for small satellites. So that's all for today. Thank you for joining us in exploring the Agnibaan. If you found this video insightful, do hit the like button, share, and subscribe for more military tech insights. Your support fuels our content. Until the next video, stay curious and keep exploring.